All right. So this is number 6 of the solution stoichiometry worksheet. It is the back, number 6. So let's read it. How many grams of magnesium hydroxide, which is the MgOH2, will precipitate if 25.0 milliliters of 0.235 molar magnesium nitrate, which is the MgNO3/2, are combined with 30.0 milliliters of 0.260 molar potassium hydroxide, which is the KOH. Now, the way to tell that a solution stoichiometry problem is a limiting reactant solution stoichiometry problem is the fact that you are given two sets of a pair of volume and molarity. So for example, with number 6, it's 25.0 milliliters of MgNO3/2 of 0.235 molar MgNO3/2. Separately, we have another volume and molarity set. We have 30.0 milliliters KOH, 0.260 molar KOH. So this is unlike the previous problem, right? Where in previous problems, sometimes we're asked how many milliliters, and we have a volume and a molarity and then another molarity, but we don't have a second volume. And we have to calculate that second volume. Here, we have a volume and a molarity. So this is the limiting reactant problem because we have two volumes, two molarities, or in other words, two pairs of volume and molarity. So let's just dig into this. I'll probably have to erase in between. I might make it small. But anyway, we're going to work with this first set of volume and molarity. And then separately, we're going to do the next set. So we've got 25.0 milliliters of MgNO3/2. We need to convert that to liters. There's 1 liter of MgNO3/2 over 1,000 milliliters. I forgot to put the question. We are finding grams of the MgOH2. Back to the stoichiometry. We've got liters of MgNO3/2. We need to get to moles. Stoichiometry happens in moles. So we will use the molarity to get to moles of MgNO3/2. And that molarity is moles over 1 liter of MgNO3/2. Now that's the solution stoichiometry part. The rest, since we are finding the precipitate is a solid formed. The rest is just solid stoichiometry, what we're used to. So we are going to use the mole ratio we are going to grams of MgOH2, so we have to go to moles of MgOH2. And that coefficient, I gave you the balanced chemical equation. So that's 1 mole MgOH2. And then the MgNO3 is also 1 mole. And this last step is what we're used to. Let me show my cancellation. So the last step is what we're used to, using the molar mass of the MgOH2. So 58.33 grams of MgOH2 is the molar mass over 1 mole MgOH2. That cancels out moles of MgOH2 and gives me grams. 0.343 grams MgOH2. Now that's for one pair of givens, the volume and molarity. Now we're going to take the second pair of volume and molarity and do the same thing. Now, a couple of things with limiting reactant. This last step is always the same, right? Because we have to compare apples to apples, right? If we go to something else, we don't know how much product is for, right? We have to keep that last step the same. So then, separately, make a squiggle. So now we're going to have 30.0 milliliters of KOH. We have to convert to liters, so it'll be 1 liter of KOH over 1,000 milliliters KOH. That cancels out milliliters, gives us liters. Then the molarity will take us to moles, to 0.260 moles of KOH over 1 liter KOH. And then now the rest is what we're used to. We need moles of MgOH2. So 1 mole MgOH2. Now the coefficient in front of the KOH is 2. It's going to be 2 mole KOH. And then now the same last step. .33 grams MgOH2 over 1 mole MgOH2. And that gives us 0.227 grams MgOH2. Now, limiting reactant, it's always choose the lowest amount of product. So we've got 0.227 343 grams of MgOH2 and 0.227. The lowest of the two answers is the 0.227. Now, the so statement only needs to have the amount of product. We could go on and say, so 0.227 grams MgOH2 are formed. Whatever reactants that gave us the lowest amount is the limiting reactant. So the KOH gave us the lowest amount, so KOH is limiting. And the MgNO3 2 is excess. Now, on solution stoichiometry problems, you kind of get lucky. Limiting reactant solution stoichiometry problems, that is, you don't have to calculate how much excess is formed. That is because we have aqueous solutions, and then we also form an aqueous product besides the solid precipitate. So we have the aqueous excess reactant and we have the aqueous product. So there's no way in the lab to tell what's what. So I'm not going to make you do excess reactant problem. There's no way to tell.